Imagine visitors from another star system showing up one day, beings far beyond anything we've known. It makes you wonder how humanity has always tried to explain the unknown. Thousands of years ago, before science gave us tools to measure and test, people still sought meaning in what they couldn't grasp, and whenever they hit the limits of understanding, they filled the gaps with the power of gods. Take ancient Greece, for instance. When violent storms churned up the sea, sailors didn't have meteorology, pressure gauges, or climate models. What they did have was Poseidon, a divine force whose moods shaped the waves. If the seas were calm, he was pleased. If tempests raged, he was angry. Natural events became personal messages from the divine. This way of explaining mystery through divine will became known to philosophers as the God of the gaps, the habit of placing a deity wherever human knowledge runs out. It's a concept with a long and even noble lineage. Consider Isaac Newton, one of history's great scientific minds. In his Principia Mathematica, Newton revealed the laws of motion and gravity, showing how celestial bodies dance through space in a precise, predictable pattern. But even Newton found limits. He realized that the planets pull on one another, that Jupiter, for example, tugs at Earth each time our worlds align. Over millennia, those pulls should distort Earth's orbit, eventually making the entire solar system unstable. Yet, clearly, it remains in balance. Newton, trusting his math but unable to explain this stability, concluded that God must occasionally reach in to tune the system and keep it running smoothly. That moment, invoking divine intervention not out of laziness, but at the very edge of profound discovery, is one of the earliest examples of the God of the gaps. Newton's faith filled the space his equations couldn't yet illuminate. Newton only called upon God when he reached the edge of what he could explain about the natural world. He didn't need divine help to describe how gravity pulls Earth and the Moon toward one another. He nailed that. He didn't need it to define motion either. Force equals mass times acceleration still holds strong centuries later. Newton invoked God only at the boundaries of his understanding, when the math couldn't yet account for what he observed. Now, jump ahead to the late 20th and early 21st centuries. What fills that same space of mystery today? In our modern world, especially with Hollywood shaping our imaginations, it's not gods we turn to when faced with the unexplained, but aliens. The God of the gaps has, in many ways, become the alien of the gaps. Think about it. Someone looks at the pyramids and says, "There's no way ancient Egyptians could have built that. It must have been extraterrestrials." But why assume that? That reaction comes from the same impulse, the discomfort of not knowing. Instead of saying, "I don't know how they did it," we replace uncertainty with a grand answer that feels satisfying. And that's the danger. Losing the courage to simply say, "I don't know." Those three words are among the most powerful in science. Because once you can admit you don't know something, you open the door to discovery. But if you demand an answer before evidence exists, you risk believing the wrong one. We see strange lights in the sky, objects that move unpredictably, and our minds leap to conclusions. I don't know what that is. Therefore, it must be aliens. But that leap, from not knowing to absolute certainty, skips the very heart of investigation. It's not that the mystery isn't fascinating, it's that we shouldn't let wonder replace inquiry. Now, what's truly exciting is that in recent years we've actually had visitors from outside our solar system, genuine interstellar objects. Scientists have long predicted this would happen. Everything bound to our sun, planets, moons, comets, asteroids, stays within the sun's gravitational reach. That's our solar family. We've sent probes, landed on moons and asteroids, collected samples, and built a detailed picture of what home looks like. But every so often, something passes through that doesn't belong. A rock or object traveling so fast that it couldn't quite have come from here. These interstellar visitors are proof that material from other star systems can wander into ours. They're not signs of alien craft, but of a living, dynamic galaxy. Worlds colliding, systems interacting, and cosmic debris exchanging between stars. And that, to me, is far more astonishing than any easy answer. According to many models of how our solar system formed, the 8 planets we know today might not be the whole story. Early on, the newborn sun was likely surrounded by dozens of developing worlds, maybe 12, 20, or even 30, swirling in chaotic orbits. Over time, gravitational interactions destabilized many of them. Some crashed into Jupiter, others fell into the sun, and some were flung completely out of the solar system. Once a planet gets ejected fast enough, the sun's gravity can't pull it back. It's gone, drifting among the stars. This process probably happens in most star systems. Every new sun likely tosses some of its debris into interstellar space, and occasionally some of that cosmic scrap crosses our path. In fact, within the past decade, astronomers have identified 3 confirmed visitors from beyond our solar system. 3 interstellar objects. The first one, discovered by telescopes in Hawaii, was named Oumuamua, a Hawaiian term meaning first scout or messenger. Its trajectory was unusual. Based on its speed and direction, scientists predicted how it should swing around the sun, but the real path didn't quite match the expected one. Normally, comets can behave this way because they release gas as they heat up, creating jets that slightly alter their motion. But in this case, no visible outgassing was detected. That left everyone scratching their heads. Now, some people jumped straight to aliens. And sure, that's one possibility on the long list, but for me, it's the last one I'd reach for. History shows us that unexplained phenomena almost always turn out to have natural explanations once we gather enough data. Since then, 2 more interstellar objects have been observed, each with its own odd characteristics. Strange brightness changes, unexpected spin rates, or reflectivity that doesn't fit neatly into our existing models. Whatever their quirks, I find them thrilling. Finally, we're cataloging material from other star systems. Each one challenges us to refine our understanding of what kinds of objects drift between stars. For me, it's far more reasonable and exciting to think these are new classes of natural objects that we don't yet fully understand, rather than to assume they're alien technology. That doesn't mean aliens are off the table entirely. It just means I'd rather exhaust every other explanation first. And that's the beauty of science. We always need more data, better instruments, more perspectives, diverse teams of researchers looking at the same thing from different angles, because humans bring biases, and even scientists can misread what they see. That's why science has built-in systems for correction, peer review being one of the most important. When you publish results, other experts scrutinize them, test them, and look for errors. It's a formal process, but it also has an informal version, that honest question from a colleague or even a rival. Are you sure about that? That's science in action. Not certainty, but constant checking, questioning, and refining.